In this video, we are going to discuss intersection of solids, in which a horizontal square prism penetrates through a vertical cylinder. Let us see the problem. A cylinder 50 mm diameter and 70 mm axis length is completely penetrated by a square prism of 30 mm sides and 70 mm axis, horizontally. Both axes intersect and bisect each other. All faces of prism are equally inclined to HP. Draw projections showing the curves of intersections. In this problem, a cylinder is standing vertically so that its axis is perpendicular to HP and parallel to VP. And a square prism is positioned horizontally so that its axis is parallel to both HP and VP. At the same time, the rectangular faces of the square prism are equally inclined to HP. When the rectangular faces of a square prism are equally inclined, that inclination will be 45 degrees. In fact, the rectangular faces of this square prism are equally inclined to VP also. Axis of both the objects intersects and bisects. The base shape of the cylinder can be seen in the plan, while the base of the square prism can be seen in the side view. We will always start with the projections of vertical objects. Draw the XY line. Below the XY line, draw a circle of radius 25 mm, as plan of the cylinder. Projected above the XY line. Draw the elevation of the cylinder as a rectangle with height 70 mm. Draw a 45 degrees line as miter line. Project the plan horizontally up to the miter line. Then project vertically from the miter line. The elevation also can be projected horizontally, to maintain the height in the side view. Then complete the side view. These are the three views of a cylinder, standing on the ground with its axis perpendicular to the ground. Since the cylinder does not have any base corners or longer edges, divide the circle into 8 equal parts. Name it as 1, 2, 3, 4, 5, 6, 7, and 8. Project all these points to the elevation and mark it as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, and 8 dash. Through the miter line, project the divisional points to the side view also. Mark it as 1 double dash, 2 double dash, 3 double dash, 4 double dash, 5 double dash, 6 double dash, 7 double dash, and 8 double dash. The base of the second object, square prism, can be seen in the side view. Since the axis intersects and bisects, mark the midpoint of the axis of the cylinder in the side view. Draw two 45 degrees lines through this point. Since the side of the square is 30 mm, mark half of it, 15 mm, on both the sides of both the lines. Draw parallel lines through these points, and complete the square. Name the corners as A double dash, B double dash, C double dash, and D double dash. In the side view, all lines are visible dark lines. There are no invisible edges. To draw the elevation, the corners of the square can be projected horizontally. Maintain half of the length of the prism, 35 mm, to both the sides of the axis of the vertical cylinder. Name the longer edges as A dash, B dash, C dash, and D dash. Project the corners of the side view vertically till the miter line, then from there horizontally, to the plan of it. Complete the plan, by maintaining the same length, as that of the elevation. The longer edges of the plan are A, B, C, and D. In the plan, the edges of extended portion of the square prism are visible dark edges. Edges passing through the cylinder are invisible. The longer edges of square prism, intersecting with the lateral surface of the cylinder, can be marked as PA, PB, PC, and PD on the left-hand side, and QA, QB, QC, and QD on the right-hand side. Additionally, intersection points on the divisional lines of cylinder also can be marked. Against the divisional point 2, R2 on the top, S2 on the bottom. Corresponding points in the side view are R2 double dash and S2 double dash. Corresponding points in the plan are R2 and S2 at the left-hand side. Similarly, against the divisional point 4, R4 and S4 at the right-hand side of plan, R4 double dash and S4 double dash in the side view. Project all these points to the elevation and find out the corresponding points in the elevation. On the left-hand side, PB dash, PC dash, PD dash, R2 dash, and S2 dash. Join these points with smooth curve. Similarly, at the right-hand side, QB dash, QC dash, QD dash, R4 dash, and S4 dash. Join these points also with smooth curve. These are the curves of intersection. Longer edges of the extended portion of the prism are visible. Longer edges penetrating through the cylinder are invisible. For cylinder also, the top and bottom portions are visible dark lines. Thus the projections and curves of intersection of a square prism, penetrated through a vertical cylinder, are drawn.